So welcome, it is section 3.2 time, which is about measures of variation. And when we use the word variation in statistics, variation broadly refers to how spread out data is. So how much variety there is in data or how spread out data is. So for example, if I just gave you some numbers, let's say I got data set 1. Let's say the numbers are 1, 5, 3, 2, 3, 4, 1, 5. And over here I have data set 2. Let's say I have 7, 14, 21, 23, 29, 42, and 10. So data set 1, notice how all the numbers are close together, right? Close together. So relatively speaking, there's a small amount of variation in data set 1 because everything's bunched together, small amount of variation. And data set 2, notice how things are kind of all over the place, right? We got a small number 17, we have a larger number 14. It goes all the way up to 42 is the largest number, so there's a larger amount. I wouldn't say a large amount, but a larger amount of variety or variation. So variation is just referring to variety, so spread out. So what we want to learn to do is to quantify variation numerically. So the first big measurement, which we're going to talk about, is called the range. The range. So the range for our data set is just the maximum, the max, minus the min. So for data set 1, the range here, if I look at the largest number, the max here is going to be 5. It actually shows up twice, right? The largest number is 5. Minus the smallest number is 1. 5 minus 1 is 4. So for the first data set, we have a range of 4. As for the second data set, our largest number here is 42. And it looks like our smallest number is 7. So we have a much larger range, 35. So it looks like our data is more spread out overall here. But range just takes into account two values, right? The largest and the smallest. It doesn't account for all the numbers in between. So we want a better measure of center than just looking at the largest and the smallest number. We want some type of measure of center that takes into account every single number to see how close together, how far away they are from each other. And the really important one that we're going to look at is what's called the variance, and then later the standard deviation. So what is the variance? This is the really important one here, along with the standard deviation is equally important. It's the average square distance. The average square distance that data values are from the mean. The average square distance that data values are from the mean. So when you're talking about population standard deviation, we have a symbol for that, variance. I should be using the word variance. we use this symbol. This is lowercase sigma. It's a Greek letter with the square. So that's population variance. We're not going to be calculating that. We're going to be focusing on just samples. So we're going to focus on sample variance. And sample variance, we use the letter S, lowercase s, and then a square over it. So that's sample variance, lowercase s with the square over it. Now, the way you calculate that, I'll give us a formula here. First of all, you're going to have to calculate the mean, the average, which we call x bar. And then you're going to take every single data value x and subtract the average. So you take every data value minus the average, you square that, and then you add all those up. And after you add all those squares up, then you're going to divide by, turns out, n minus 1. N minus 1, n is going to be the sample size. So again, I'll list what these symbols mean. The capital sigma, it looks like a backwards E sort of. This just means add up. X represents data value, so a single X would be a single data value. X bar represents the sample mean, the average of the sample. And n would be the sample size. So how many data values there are in total. All right, so the thing about sample variance is when you calculate it, it's going to be in square units. So variance is going to be in square units. So here's a little note. Variance is going to be in square units. So it turns out to be in square units because you do that square there. This square right here guarantees you're going to have square units. So variance has square units. So for example, if I were calculating the variance for salaries, my final answer would be in square dollars. Now that's kind of awkward to talk about like square dollars to square units sometimes. Sometimes it makes sense to talk about square units, like square inches make sense. When we're talking like money, square dollars would be very odd. So rather than keeping square units, what we often do, we calculate something called the standard deviation. Standard deviation. So standard deviation can be calculated immediately. I'll call it sample standard deviation. Once you have the variance, you calculate the standard deviation. We call it lowercase s. It's the square root of s squared. The square root of s squared. So that gets your units back to ordinary units, so you're no longer dealing with square units. So for example, if I had s squared was in square dollars, then I take the square root of s squared, and that's just going to be in ordinary dollars. So it's a simple calculation. Once you calculate s squared, then you can just take the square root of s squared to get the standard deviation s. So standard deviation is also a measure of spread outness, a measure of variety in the data. What else do I want to say about that? I think that's it. I think I just want to start working a problem. Oh, the bigger the variance, the bigger the standard deviation, the bigger the number you calculate. That means the more spread out your data is. The smaller the number, the smaller the variance, or the smaller the standard deviation, that means the closer together the data is. Let's do an example here. Example. A sample of 5 type 1 diabetic women are weighed and their weights in kilograms recorded. below. $64, this is kilograms. 73, 66, 70, and 78. So what do we got? 1, 2, 3, 4, 5. So first of all, part A, find the mean. Find the mean of the sample, right? We got a sample. We're going to call it X bar. Okay, so how do I find a mean? So X bar is what? You add up all the data values and divide by n. So what I'm going to do, I'm going to add up all my numbers. I'm going to do what? 64 plus 73 plus 66 plus 70 plus 78. Did I add those up right? Oh, let's make that last one 77. Let's change this last one to 77. I like 77 better here. And change that to a 77, this last number. 77 would be a better number. Okay, I'm feeling 77. 64 plus 73 plus 66 plus 70 plus 77. Okay, 350. And we're going to divide that by the total number, n, right? 1, 2, 3, 4, 5. So X bar, the mean here is 350 divided by 5 is 70, right? Okay, so we got the mean. So part B, I want us to find the variance. Find the sample variance, the variance, which this number will tell us how spread out things are. Remember, it's the average square distance that the data values are from the mean. All right, so what we're going to do, I'm going to make a table. I'm going to put an X in the left-hand column here. And also, I'm going to write down all my data values. What do I have? I have what? 64, 73, 66, scroll a little bit more, 70 and 77. And 77. So I've written down all my data values. Let's scroll this up some. Okay. Now in the next column, I'm going to call it X minus X bar. X minus X bar. Now where exactly am I getting this X minus X bar from? Well, if you remember your formula here, right, it was what? S squared is what? X minus X bar squared. You add those up and you divide by n minus 1. So right now what I'm working on this X minus X bar right here in the formula. So that means I'm going to take every single data value in my X column. I'm going to subtract X bar. So I'm going to take 64 minus 70. I'm going to get minus 6. I'm going to take 73 minus 70, and I'm going to get 3. I'm going to take 66 minus 70. I'm going to get minus 4. I'm going to take 70 minus 70. I'm going to get 0. I'm going to take 77 minus 70. I'm going to get 7. Okay? The next thing I got to do, I got to square this column. So I'm going to make a new column. I'm going to call it X minus X bar. And I'm going to square this column. So remember, when you square negative numbers, they're always going to be positive, right? If you wanted to put that in the calculator, you put negative 6 in parentheses, right? Negative 6 in parentheses and square that. But we know negative 6 times negative 6 is just positive 36. We can do simple math. 3 times 3 is going to be 9. Negative 4 times negative 4 is going to be 16. 0 times 0 is 0. And 7 times 7 is 49. Just remember, when you're squaring a negative, it's always going to be positive. All right, now look what your formula tells you to do next. What does your formula tell you to do next? It says this symbol right here, this big backwards E called the capital summation or capital sigma. That means you're going to add some dudes up. So I'm going to put a little summation here. And in this box at the bottom, you see that box there at the bottom? I'm going to add up my numbers. So what happens when you add up your numbers? It looks like I got 36 plus 9 plus 16 plus 49. I get 110, right? 110. Okay, so I got that total there. So s squared is going to equal that entire total, which is 110. And then you have to divide that by n minus 1. What was n? What was n? Well, how many data values are there? You said there are 1, 2, 3, 4, 5. So we're going to divide by 5 minus 1. 5 minus 1. So s squared is going to be 110 divided by 4. So what is that exactly? S squared, come on, man. Come on, man. It's not, there it goes, 110 divided by 4. Great, please. Thank you. It's 27.5. Okay? That's the variance. That's what we were asked to find, the variance. So this is the average square distance that the data values are from the mean being 70. Now, the last step I want to do here, I want us to calculate the standard deviation. Find the standard deviation. S. So how do you find standard deviation is the question. Well, remember your formula. Standard deviation is the square root of the variance. So it's going to be the square root of 27.5. So if I take the square root of 27.5, I get about 5.2. 5.2 approximately. Right, you get a decimal. You're going to have to round it off somewhere. 5.2 would be fine. Now, if you want to get a little more accurate, you can go to another decimal place. Generally, the strategy is to go one more decimal place than the data set itself. So remember the original data set. You look at these numbers, 64, 70, 73, 66, 70, 77. They went to the ones place. So, I mean, generally you go to the tens place. You go to the tens place. So that's fine. But sometimes I like to go an extra decimal place. That's just me. So 5.2, 5.24, either one's fine. All right, so that's calculating standard deviation. So notice that s squared, this is in terms of kilograms squared, and s is going to be in terms of kilograms. All right, I think we're going to end it there, and we'll